Okay, people are still joining. Hello, everyone, depending where you're joining us from. Good morning, good afternoon. We still have a few people logging in, so please stay tuned. We're gonna start in 1 or 2 minutes from now. So there's still a lot of people in the lobby coming in, so stay with us. So we give it 1 more minute. So there are still people logging in. So 1 last minute and 3 minutes past, we're gonna start. Make yourself comfortable. I hope you have a nice coffee or tea in front of you. I hope you can all hear me. So I think we are good to go. So good morning, good afternoon. My name is Jost Wagner, and I'm going to be your moderator for today. Thank you for joining us for the first edition of the regional webinar series on green chemistry. How can the textile sector solve one of the biggest challenges? And when we talk about which challenge here, we talk about the challenge of making textile green. So before I hand over to the representative of the hosting organization GIZ-FABRIC, we have prepared a small survey for you to find out who's actually joining us today. So in a second, my colleague and technical facilitator, Mr. Ajman, will share a link in the chat. So you have to click on the chat button on top of your screen, and there should be a link. You can click on that, and there you're going to see choices. And we ask you to decide which stakeholder group you belong to. You might have the difficult question that you might feel you belong to more than one. Just choose the one you feel that is the most suitable for you. And we're going to see the results live on the screen. So any second. So please click on the link and choose which stakeholder group you are presenting today in this webinar. And there are still people joining. So we're going to be a large group, and you can see on the screen live how the numbers are going to change. And I hope you can click on the link in the chat and you can come to the Mentimeter survey. We're going to use it twice today, Mentimeter. So this is the first one, and at the end of the webinar, we're going to use Mentimeter again. And we're already seeing that we have a very diverse group of participants today. So if you have just joined, welcome to the regional webinar on green chemistry. And we have a small survey for you. Please go to the chat, click on the link in the chat, and decide to which segment of business you feel you are belonging to. While a lot of people are still joining. So we are already more than 150 people today, and we are expecting many more. So one more time, please go straight to the chat, click on the link, and let us know which segment of business you belong. There's still a lot of people who could actually do the survey. I hope you found the link. I hope your website opens on your mobile device or on your computer. And if you look at your MS Teams, you will actually see the results live shown by my colleague here. And we can see that there, especially a larger group from the textile producers and also from the textile brands. So you can continue doing that, but let's start. So let's not spend too much time. I think we are now in full force, and let's start the webinar right away. And I have the pleasure to introduce you to Mr. Gundolf Kleen, who is an expert on the implementation of capacity development programs of GIZ, focusing on chemical and environmental management within the textile industry. So he worked across the region, Pakistan, Bangladesh, Cambodia, and China, as well as in Germany. And he is also currently leading the environmental topics on textile within GIZ Asia. So I hand over to Mr. Gundolf Kleen to say a few words on behalf of the organizers. Gundolf.
Thank you. Thank you very much, Joost. Warm welcome from my side. I'm very happy to see so many participants in the room for today's session on green chemistries for textile producing. And I'm also very happy when I see the results from the Mentimeter, because we have our main target group here, for which we are also offering the exchange and the information from today and also in the next two sessions, once the producer and also the brands, which are also quite important and one of our main cooperating stakeholders for the project. I would like to give you a very short overview of the background of the GIZ program and why we having and hosting the sessions today. GIZ-FABRIC stands for Fostering and Advancing Sustainable Business and Responsible Industrial Practices in the textile, garment, or clothing industry in Asia. The project is being implemented on behalf of GIZ, from GIZ on behalf of the German government, to support the knowledge sharing and sharing of good practices of the textile industry in the Asia region. The project is being implemented in 6 countries, from Pakistan to Bangladesh, Myanmar, Cambodia, Vietnam, and very closely we're cooperating with stakeholders from China in the region. The interest and the reason why we have organized the session and the exchange today is that the textile and garment manufacturers are facing with several challenges, and one of them is of how to, or what are the best chemicals being used in textile wet processing units. On the one hand, it's quite common. It's common sense that, of course, textile industry is one of the heavy polluters to the environment. On the other hand, we want to make it more sustainable to reduce the harm to the environment. We have the pressure from the customer, final customer at the end. They want to buy good and sustainable garments and clothes which are not doing harm to the environment, not doing harm to workers. We have the brands who also have a higher interest to fulfill this needs and interest, and also to make the supply chain more sustainable. And we have at the beginning the producers, which have also and are aware about the pollutant, but they are also facing with the challenges of the cost of production. And the interest, and also what is often said is, oh, if we go for the better chemicals, the greener chemicals, the price is higher for that, we have to increase the cost for the production. And I think, yes, it's true. Of course, the more sustainable chemicals may have a higher price per kilogram, but often also comes along with several benefits. And that is what we want to explore in the 3 sessions from today, next week, and the week after, really to see if the price is only one of the arguments to neglect or not going for the greener chemicals, because of course is doing less harm to the environment. It might increase the productivity and the efficiency in the production, and therefore I would like to invite you, also the speakers today, and also to contribute during the chat. We will also get to know how you can contribute and raise any questions later on for today. And I'm very happy to welcome you once again, as it's a challenge which cannot be taken up only by one further producer. It also have to be taken up by the chemical supplier, which have to provide the solution, and we want to get to know if that's really true, and if what kind of solutions are there, if how they can made available or how they are available in the production countries, and also the brands which may also convey the message then later on to the supply chains, etc. So I would like to hand over back to you, Joost, after this brief overview overall, and looking very much forward to get to know about that possible solutions regarding green chemistry. What does it mean, and how producers can they take up? And I'm also looking very much forward to your questions later on in the chat. Thank you very much.
Thank you very much, Gundolf, for these introductory remarks. And it's very obvious this is a topic of very much interest to many people, as we are reaching the 200 people mark, as the number of participants are still going up. So once again, my name is Joost Wagner. I'm going to be your moderator, and we have hopefully prepared a very interesting program for you. And if I can see the overview slide. So the next slide, please. So we are going to have a quick introduction now how we're going to run the webinar, and we are going to have 3 presentations for you. Again, my slides are not moving. I guess you see the slides right now, but we have 3 speakers for you invited. We have Dr. Klaus Kümmerer from the University of Lüneburg. We have Mr. Shivendra Parmar from TÜV Rhineland, India, and we have Ms. Mariella Noto from the ZDH Foundation Roadmap to Zero program. And they will give 3 very interesting presentations back to back. And the remaining time of our 90-minute webinar, now 75 left, we're going to use for communicating with you and our speakers. So what we are going to do is quickly tell you how we run the program. First of all, this webinar is being recorded, so be aware of that. Secondly, if you want to engage, we want you to make heavy use of the chat. And so the mics are muted at all times, but you can ask questions and comments in the chat. And if you have a question and someone else sees it, you can actually go on the question with your cursor and give it a thumbs up. Okay, so maybe we can do a test. So I can write now in the chat, thumbs up. So if you see the message thumbs up, you can go on it, and then you can actually give it a thumbs up with the reaction menu. So, and if there are many thumbs up and we have too many questions, we try to address as many as possible, but the most popular will probably answer first. If you have a question to someone specifically, please mention first in the question who you are addressing. And so I think you already know we had a Mentimeter poll. Some people who were coming in late. Later, we have another Mentimeter for the evaluation. 1 question, so please stay with us and help us to get feedback from you. So again, if you have any comments during the presentations, please be so kind to write them in the chat. We unfortunately don't have the time to, with 200 people, to unmute people and then have a long conversation. So here we go. We're going to start right away, and I'm going to hand over now to our first speaker. And you can already see the PowerPoint being on your screen. We have invited Dr. Klaus Kümmerer. He's the director of the Institute of Sustainable Environmental Chemistry. He's also the chair of Sustainable Chemistry and Material Resources at the University of Lüneburg and the director Research and Education of the International Sustainable Chemistry Collaborative Center in Bonn, and also a certified chemist, I saw. So full of expertise. Dr. Klaus, we are very happy to have you. The next 15 minutes are yours.
Thank you for the introduction and for the invitation. It's my pleasure to share some bits and pieces. Why I'm saying bits and pieces? Because as you can see in the next slide, if we talk about textiles production, use and recycling, it's a very complex system. Yeah, and I will try to address a few of these, and the references are given so you can see it later on, look it up. But this just demonstrates you what we are talking about. We are not talking about one single chemical or one single process. I think many of you are aware of this, at least within their field of activity. But if you go for a complete picture, then it's much more. And much more also means some data here. For example, there are estimates from Sweden that around 2,000 chemicals are in use for textile production. Of these are 165 either carcinogenic, mutagenic, or toxic to the reproductive system, and others. The first I mentioned, these are the most dangerous chemicals, the most dangerous properties. So to avoid them is in the interest of your customers, but also in the interest of your workers. If you lose workers and you have to train them again, etc., it starts already with causing costs, let alone the costs, the burden for the environment. And also you have to be aware that 90% of the initially introduced chemicals to textiles during the production stay on the fiber, they stay in the textile. So if we talk about waste, and I will show you some pictures later on, please be aware that it's not just the fiber or the textile and maybe a little bit of dye. It's a huge mixture of chemicals. And in total, we have about 5 billion kilogram of dyes, pigments, and finishing chemicals currently used. So again, a huge amount, a huge diversity. And in general, at a global level, and you may look up the data for your country individually, 20%, 1/5 of total industrial water pollution is by the textile sector. And I guess some of you already came across in your own country that more and more states and governments take actions to reduce this. So there is no choice to adapt or to decide or to save or not. You have to. That will be the future. I would say that's one of the first summaries, maybe. And just another example, high structural diversity of substances. So it's not only products, it's lots of different chemicals. That means different properties. So we say we are humans. That's an analogy. We could say they are chemicals. I see we are more than 224 people now. We are all individuals, so we behave differently in different situations, and the same with chemicals. So another aspect of this diversity. Let's have a look on a probably simple product, you would say, or the customer would say. But here it starts already. So we have a basic fiber, the polyester, PET, mixed with cotton, mixed with elastane, polyurethane for the attachments, for example. Then we have dyes and so on. As I mentioned already, here another figure, 600 chemicals for textile manufacturing. I mentioned already, it depends. Some data are much higher. So that also indicates we have not a complete knowledge. Do you have a knowledge of the textiles of the chemicals in your textiles, which are used in your company, which are on the product you're buying, you're selling? Maybe you should start to get the data, because you need this information. Then you can think about substituting. Then you can think about getting greener. And also always think about, we'll come back to this later, how to reduce complexity. I mentioned already waste, and we also have to be aware that textile waste is still much increasing. And an important point is that environmental, social, and economical effects, and also ethical issues, do most often not happen at the place of synthesis or production, and I could add of use. Yeah? So we have to be aware of this. And as already mentioned, many chemicals still stay on the fiber, and if they are just dumped, they pollute groundwater, and groundwater is essential for living. We all need water, clean water, and it's also important for keeping being safe and healthy. So the determinants of a chemical footprint, and what we know with chemical footprint of a textile, the mixture of all the chemicals that are used to get a certain textile and the chemicals that are still there. It's like a fingerprint, and it relates to the fiber or the fibers, the methods and technology of production, and performance requirements. Yeah, and these again are related to the use phase, and also have impact, as already mentioned, at end of life. Let's have a look briefly on another big picture. On the left side, you see chemistry. If we talk about chemistry, maybe you think back to your old school days. But chemistry is, and that's what we call a science, it's non-normative. That means chemicals do what they do, behave, how they should behave under given conditions. We cannot influence this, or we cannot change this. We can influence or change the conditions, then behave differently according to the new conditions. If we use chemicals, then we enter the realm of what we call a broader normative framework or normative framework. Nature does not tell us what is good or bad. It's our decisions. If we think greener is better, then it's our normative framework. And as you can see here, chemistry we should talk about greener. There is no absolute greenness. We only can compare. Therefore, it's important that you know what you're already using. Then you can compare if you are substituting one chemical by another. And there are the 12 principles. I will not go into details. And then you can compare and make your decision. And then you have to think about also, or know that not everything which is green or greener fits into a circular economy. You can come up with nice green chemicals, but maybe they hinder recycling or long life circulating. So it's green, but it does not fit in the circular economy. This we have to better understand. And green chemistry is not about the products themselves, but circular economy. And also you probably know that not everything which fits in a circular economy, there are clear limitations, fits into what we call sustainability. And that's the bigger picture, sustainable chemistry. Just to mention, I will not go into details here. Important for all this is the word design. If you're a textile designer, maybe you have a different understanding, but you know, to design is to decide from the very beginning what to use and how to use to come to a certain product. So we should start to think about service and function, which is really needed. Maybe not all the appliances are needed. And if you have lots of appliances, then they make your product very complex. And complex means you need more resources, maybe more toxic chemicals. You have to pay for the resources, and it's challenging recycling. And therefore, we should think about to design for durability. But then you may say, oh, then I cannot make money anymore. But then you can go for design and repair and maintenance. So you have a different understanding of your product and the chemicals you are using. You are interested that they work as long as possible, and the follow-up business you do by advising, by repairing, etc. And always someday there's a need for recycling, and therefore it's important that you can easily separate the constituents of a textile, for example. And then you can recycle the different fraction. And as for wastewater, the production, design for input is very important. We have already data zero discharge, which show us what is possible. And it's not just to save the environment, it's also you can regain the chemicals, salts, etc., and you can use again, saves you a lot of money, at least in the middle and the long run. And if there are chemicals which cannot be retained, then these have to be designed for complete mineralization in the environment after the introduction into the environment. That's part of our research. If I would talk to chemists only, I would have focused on this, but I think the audience here is not so much interested in this. So I will not go into details. What does it mean, a greener design? We have to reduce complexity, toxicity on all levels. That starts with the elements and the chemicals that are used, because we cannot synthesize elements. Metals, for example, they are formed within the life cycle of a star. And we have to design products for recycling. We have to design avoid products, and the same holds for processes. Keep it as simple as possible. Saves you money, brings you safety, etc. Yeah, and you have to think beyond molecules, materials, and products from the very beginning. To avoid rebound effects, I talked already about reducing diversity. Be responsible, develop ownership from the very beginning of the products, of the chemicals you are dealing with, and ensure traceability. If you do not know where it is and what it is, you will never be able to recycle it. And recycling in the future will be also of interest for producers, because if you are able to recycle something yourself, then you have access to resources, to scarce resources maybe. So think about this. And there are metrics, how to know what's better. You should think of this and to use this. And change traditional chemical practices from bigger, faster, etc., to adapted, better, safer, and less complex. That's really the future. And also there are the 4 R's, as already mentioned. Start with be responsible for your product along the whole life cycle. If you're an economist, please do not think only on value chain. The value chain ends where there is no value anymore from your point of view. That's one of the reasons why we have to deal with waste. Waste is not valorized. And therefore people think there's no money in, just discard it. That will change in the future, because of the shortage of resources. And also it's important, if you want to really come up with new good products, with greener and more sustainable products, keep in mind the whole life cycle from the design, starting the design, resources synthesis. Reduce, I mentioned already, is important because what's not used generates no problems. Reuse whatever is possible, if it's from the effluent, for example, if you get the fibers, etc. And if you are the one who gets back the textile for recycling to get out the fibers and other chemicals again, then you really will start thinking about how to design your product, because then you have to deal really with the complexity. And as for recycling, there's a small hierarchy. I will not go into this in details now here. If you're interested to export your products to the European market, there are lots of regulations. You probably know the latest is, it's not a regulation, it's even a policy. That's the so-called Green Deal of the European Union. You can easily look up in the internet. And within the Green Deal, dealing mostly with carbon dioxide emission reduction, there's a chemical strategy for sustainability, CCS, and also a strategy sustainable by design, SSBD. And this you should have a look into. It's under discussion. Tomorrow I have a meeting on higher European level. It's under discussion, but the constraints will become tighter. That's what I can tell you. And there's also a strategy for non-toxic environment. So the EU has developed huge interest to make all these things greener on different levels. And that will also go into regulation in the future. Yeah, here if it's about innovation, just the green ones from sales to service orientation, I think is an important keyword. And there are some others, new business opportunity, just mentioned, maintenance and advising of precious textiles, not just throwing away. That would be one example here. So summarizing a little bit, building blocks for greener and more sustainable textile industry. Saving resources saves money and market dependencies. Think of shortage of accessibility. New business models present new market opportunities too and are related to the first bullet point. So service and function orientation results in new business opportunities, one could summarize here. EU Green Deal and sub-strategies will be a future driver, and as we have learned from the chemicals regulation REACH, this will probably have also impact in the midterm or long term to all countries. Less chemicals and lower complexity does not only save you money, it saves you also time. Yeah, and also I think everywhere there will be a more sustainability-oriented consumer. Ethics is also important related to these topics. So yes, go in this direction. There are lots of opportunities. And now just 2 slides, the advertisement block. If you want to learn more about how green chemistry and sustainable chemistry are linked, there's a YouTube link, a presentation in English you're invited to listen to. And also there is a conference next year in May, where we also, if we get enough abstracts, we will have a session on greener and more sustainable textiles. Thank you for your attention.
Thank you very much, Dr. Klaus Kümmerer, for this introductory presentation, Building Blocks for Greener and More Sustainable Textile Industry. Some people already asking if they can get a hold of a copy of the presentation. I also understand there were a few people, I think due to bandwidth, couldn't follow your presentation, and some other people joined a little bit late. So I understand we can make this presentation available, as well as Mr. Chi from GIZ asking to share your paper you mentioned. So maybe we can put that on the website, and my colleagues will put in the website in the chat at due time during this seminar here today. Thank you very much, Dr. Klaus, and let's go straight to the second presentation. And again, to everybody, also to the colleagues who joined late, if you want to engage, please write questions and comments into the chat, and we try to address as many questions to the speakers at the end of the 3 presentations. So our next speaker is actually an expert from TÜV Rheinland, India. He is a senior technical manager, and I think I saw already his presentation on the screen. And can you bring it up? Okay, I think I also have a little bit problems with the screen here. So the title of his presentation is Chemicals Creating Non-Conformities in Textile, Harmful to People and Planet. So Mr. Shivendra, the floor is yours for the next 15 minutes.
Yeah, good morning, everyone, and thanks for giving me this opportunity to speak on this topic related to sustainability, chemical creating non-conformity in the textile. So here we'll discuss about like we have discussed in the previous session about the legal compliance. So I'm just want to brief on that before discussing about the chemical importance and all that. Then when we are thinking about the product and safety compliance, it is somewhat related to the complete cycle within the industry, and there are some basic elements which are related to this different types of industries for textile, shoes and apparels. So overall, when we talk about the sustainability, it is talk about the chemical management and the input chemical control. So we need to take care about that, and procurement policies we need to think on when we talk about the supply chain compliance also, and related to the different finished product requirements for the final garments, like RSL related to that. So input chemicals, if we will have monitoring at that particular level, it play a very major role. And then when we talk about how to manage the chemical, either through the transportations of the dangerous goods. So there are certain guidelines which are related to the chemical handling and all that need to be taken care. within the factory to maintain this chemical management and how to dispose it off. So for that, we need to know about the chemical and basically why we need to manage the chemical. So first reason that each stakeholder must take a responsibility sorry, for the health and the welfare of the existing and the future generation. And the second reason is to understand the hazards associated with the chemical use in the manufacturing process, either in the textile industry or a leather industry, so that the proper risk control measures can be implemented and to address the concerns for the buyers or consumers and other external stakeholders. So that is also the things. So when we talk about to know your chemicals regarding that, so everyone should have the knowledge who are using that particular chemicals, and even the brands and retailers which are associated with the manufacturer, they are also promoting the manufacturers and to have the knowledge about the chemicals which they are dealing with, so that they will use the non-hazardous chemical within their industry for dyeing, printing, or different type of wet processing within textile industry. And there is a good technical documentation available with the chemical when you procure the chemical from any chemical supplier or formulator, which provide very useful informations and related to chemical, how to use it, what are the hazard associated with that. So based on that, basically we came to know whether how much hazardous is that, and whether as per our sustainability requirement, as per our end product requirement, whether we are fulfilling that particular guideline. So one of the advantages, and there is a one good technique for that, to prepare the chemical inventory list, which is useful to provide all the information, what are the hazard associated, whether it is a health related hazard, whether it is an environmental related hazard, whether it is a physical hazard. So that all informations can be provided with the CIL. So everybody knows about that, and the case number. With the help of that, there are certain different global portals are also available. With the help of the case number, you find the basic properties related to that, and as per the GHS Global Harmonized System guideline, what are the hazard associated with that, we also came to know. So if there is some detection in the finished product or in the wastewater also, so we can do the root cause analysis and find out the alternative related to the chemical, which due to which basically causing the detection in our finished product, like our apparels or garments or home textile, and use the suitable alternative also for that. In continuation of that, I just want to tell you that generally when we are thinking about knowing of the chemicals, so we are referring to the firm group for the hazards and the sources related to that. And it is one of the important document which we can refer and to find out the where the particular sources are available related to, like the example is there in front of you, like alkyl phenol. These I will go in detail in the next slides also for that. So this can help as a chemical text manufacturer also, who are using different types of chemicals, to find out the root cause analysis through different process like 5S or fishbone diagram, so that if there is any problem or related to the chemical detection found in the finished product. And when we talk about these are some possible actions related to the knowing your chemical or health characterization related to that, that provides supplier with positive chemical list and updates the brands and retailers about that requirements and all that thing, and create a product chemical footprint, so that we should have a complete process knowledge about the chemicals and all that. Here, as we talk about the hazards associated with the chemicals, so everyone knows about the sustainability, like when we more go into the hazard properties related to this, they are categorized into persistent, bioaccumulative and toxic, and very persistent, very bioaccumulative, carcinogenic. It is related to the cancer type diseases, mutagenic and toxic. So it is a health hazard related issues to that. And indocyanine disruptor is one of the problem which is related to the DNA or body functions related issues. If we are using that particular product which contain some certain hazardous chemical, so automatically this type of problems are there, like persistent, as you know, that they are not easily degradable. It will take decades to biodegrade themselves. And these diseases like carcinogenic cancer related issues and all that. So it create a lot of problems. So that's why it is all our initiative to work on that, to use the non-hazardous chemical within the supply chain, within the wet processing process in the textile industry. Here, afterwards, I just want to give you some brief about some parameters which we are using hazardous chemical, which the products which we are using have contained this hazardous chemical parameter, and due to which the different types of problems have been created. Like one of the example is organotin compound, which are used as a antibacterial or antifungal agent due to their biocides properties. So they are so from this you can came to know that what are the sources from where this organotin compounds can be found. It can be used as a thermal stabilizer for plastics, as catalyst and polymer synthesis and all that thing. So they have various use in textile and leather industries. And as I told you, that organotin is a very hazardous parameter, or which is even as per the legal regulations like REACH and all that, it considered as a banned. So beyond any detection, like it will be hazardous. So why it has been hazardous or why it has been restricted? Because it has been persistent, bioaccumulative in nature, toxic and very persistent and very bioaccumulative. So as I mentioned that while reviewing the MSDS also, these type of information can be available in the MSDS key, whether the chemical which you are using, if any these anti fungal agent or biocide agents we are using. So if you found this type of organotin compound in that, so we can use an alternative chemical to avoid the hazards present in our finished product. So it can be found in like these are the sources like PVC, PU coating, polyester, plastic trims, textile, leather, screen prints, biocides and pesticides. So with the help of that, we can do the root cause analysis. Like if you have a finished product is having a PVC coating. So with the help of that, we can came to know, okay, we have the PVC in that. So maybe the chances of presence of organotin compound is there in the PVC. So then we can find out, okay, these are the chemicals which we are using for that particular coating. And then if we detect, okay, this is the chemical due to which the organotin compound has been detected in our finished product, then try to use an alternative chemical which does not have this organotin compound. So that's how we can do the root cause analysis also, and to use an alternative for that. So these are the I already mentioned about that property, like they are using as a thermal stabilizer and as a catalyst in polymerization process also, and as a biocide for the preservation. So it will, due to this concern, the organotin compounds chances of presence in the finished product is there in whether when we talk about our textile industry. So how can we avoid it? As I already mentioned that when we detect that there is an organotin compound in our finished product, then we can first of all do the root cause analysis, find out where it can be found, and based on the sources and all that thing, and then we can come to the conclusion to use an alternative which is best suitable. And there are different lot of sources are there who's providing the non-hazardous this stabilizing agent and catalyst which does not contain this organotin compound. One of the another parameter which is having the issue in most of the textile industry, because when we talk about the sources of this chemical parameter APO, it is found in most of the product, and it has been connected with a lot of sources. I just shown to you in the next slide. So APO is one of the major problem, and most of the factories, when they will join our session, they talk about that particular issue. They talk about that alternative problem solution also. They will do the hot boiling of that product, and they will solve that APO issue in that particular textile product. And there it has been specified that a lot of suppliers came to us that when they have used the non-hazardous chemical and they focus on the input chemicals and to remove the particular actual particular source from where the APO has been found and use a chemical particular chemical which does not contain this APO. So automatically the problem is solved, and using a temporary solution like hot boiling and all that, it is not a permanent solution. So better to go to use a certified chemical. Ask your chemical supplier and formulator to provide a certificate. Like when we talk about like there are different blue sign, eco passport, or ZDHC, ChemCheck certificate. So to ensure that that particular the chemical which you are procuring does not contain these type of chemical parameter which are banned or restricted, and which create issues in your finished product, and even found detection in the wastewater, which further affect the environmental also. So that's the message from my side. And related to the alkyl phenol, why it has been restricted. So very toxic to aquatic life. So with the help of any pictogram in that your MSDS, there is a different pictograms related to different type of hazards characteristics. So you can also easily find out whether it is physical related issues or health related issues or environmental related problems are there. And there are some alkyl phenols which are damaging the human fertility and unborn child also. So these are all the problems which are associated with the alkyl phenols. And when we talk about their sources, so I just give you the brief. There are a lot of things where the APO has been found. It is found in the laundering detergent. It is found in the scouring agent, weighting agent, softeners, even the yarn, the maintenance oil, that spinning oil. I just want to tell you that there also the chances of detection is there. So everywhere, if you see, there are a lot of sources from where the APO can be transferred to the finished product. So from with the help of that, if you want to go through your complete wet processing line, and if you found, so APO is one of the major problem in most of the textile industries. But nowadays, after using an alternative and non-hazardous chemical with this using of certified chemical, these problems are also solving, and we are getting good feedbacks from the manufacturer also related to the reducing these APOs problem. And I just want to summarize it at last related to these sources and all that thing from where, like when we already talk about APO, it is found in cleaners, detergents, sizing agent, flame retardant has been found in flame retardant finishes, heavy metals. It is one of the common parameters. So while when we are also in the testing third party lab, we are doing testing on behalf of ZDHC related to that, and referring the chemicals for performing different types of testings also. So there also heavy metal is one of the common parameter which is mostly found in most of the different types of chemical which is coming for the particular testing related to that. A short SSCP, MCCP, it is found in the leather conditioners or tanning. It is a greasing agent which has been used. So while showing this particular table, I just want to just highlight that with the help of these sources and all that thing, if you see that how the hazards are associated with different typical use agents or auxiliaries or chemical which are used in the different wet processing process like desizing, scouring, washing, dyeing and all that. So as a factory, as a manufacturer, it is our responsibility to take care to maintain a better chemical management within the industry so that chemicals could be using of non-hazardous chemicals could be controlled at the initial level by using a certified chemical, and automatically your finished product, there is no any hazards associated in that. Even your wastewater or results are also good as per our current requirement. So that's all from my side, and I just want to share with you that across from on behalf of TUV, we have a global team across all over globe, Europe, North America, in EMEA, Bangladesh, India, and Pakistan also. And apart from that, Asia Pacific, we have Cambodia, China, Indonesia. So if you have any requirement related to chemical management trainings, audits, and all that, we can support from that. And these are all our contacts from Pakistan, Bangladesh, India also. So as it has been mentioned, related to the REACH certification, REACH requirement, and even chemical testing and MSDS preparation related to the chemical supplier and formulators. So for that also we can support. So if you need any support for the root cause analysis also for the factory, we can support for that also. That's all from my side. Thank you.
Thank you very much, Shivendra Parmar. So this was a very interesting presentation. And again, the questions came how you get hold of these presentations. So please do not forget that all the presentations will be uploaded to the Asia Garment Hub website. So if you go in the chat, you see 2 postings already with the link to the asiagarmenthub.net. So we go straight to the third presentation, and I want to invite you again to write your questions and comments to any of our speakers in the chat. We have 3 questions so far. So do not hold back. So you have a better chance to get your question answered if you put them in the chat early. So I have the pleasure to invite you to our third speaker for today. We have with us Mariella Noto. She's the Implementation Senior Manager at Implementation Hub in the Netherlands, if I'm not mistaken, based. And she's part of the ZDHC Foundation Roadmap to Zero program. We are very happy to have you with us. Good morning to you, and the floor is yours for the next 50 minutes.
Yes, and I just want to double check if my screen is visible.
In the moment it is, yes.
It is, okay, good. Then I know that that's actually running. Yeah, thank you very much for this opportunity to speak here. I'm going to hopefully give you some insight and bridge a bit the gap between all of the different parts that were already mentioned. So I was very happy to hear Shivendra just before us, who is also one of our approved trainers at ZDHC, and who is next to me and also my colleague Phil Chung this morning here with you. So what we will discuss, we will go through it very briefly because we know we only have 15 minutes. And of course, we are very much aware that we cannot explain, everything around input management and chemical inventories in only 15 minutes. But we will, of course, be able to give you a few highlights and elements of what we actually do to support suppliers and also brands with getting more insight in chemical management and more specifically also chemical inventories. So that is what we will do in the upcoming 15 minutes. Now, as some of you might already know, the ZDHC has a holistic program which contains input management elements, process management elements, and output management elements. Around the input side, and that's also something that Shivendra was also referring to, we talk about the chemistry that's going into the facility and into the production process. The ZDHC has created a ZDHC MRSL that we will come back to a little bit later. That's all related to, okay, so which chemistry that you are using in your facility should actually be restricted and not be used anymore because they are creating this hazard to the environment that also Shivendra was already mentioning. So if they're, for instance, carcinogenic, of course, we don't want you to use them in a certain way or up to a certain level within the industry. So the input level side, input management of your chemicals, how you process them during your manufacturing, and how they are coming out of the facility in terms of your wastewater. Now we will focus on the input pillar in this case today, because we're talking about input chemistry, and I would like to bridge it also to what Shivendra was doing before me. So what ZDHC has been what ZDHC created from the beginning is a ZDHC MRSL, as I already explained before, a manufacturing restricted substance list that includes chemicals that hazardous chemicals that should be eliminated from use within the production process. To support this MRSL, this list of chemicals, which is available online as a database where you can search. So it's not only a paperwork, let's say a document, but it's also a database. We also created a conformance guidance to support you in looking at, okay, so how can I use this MRSL, this manufacturing restriction substance list, and how can I actually eliminate step by step the chemicals that I have at my facility. The set rules and standards in the documents are reflected also in a platform that we have, which is called the chemical module. It's based on the ZDHC Gateway, which is an online platform, and which is basically also connected to our ZDHC manufactured restricted substance list. This tool has been practically set up to support suppliers like yourself to look at, okay, what do I have in my facility currently as chemicals? Are they conformant? How hazardous are they? And how can I actually replace them in the future by chemicals that are less hazardous? And of course, that's in the end what we want to do. We want to create a solution, and that's very well indicated by Shivandra as well. We want to create a solution that you can use to actually look at alternatives that you can use at your facility. So not that you cannot, produce certain things anymore, or need to stop working in a certain direction, but how can you keep on doing the things you're doing, but with less hazardous chemicals? So the underlying documents that are related to this are the manufacturing restricted substance list available online, and also the MRSL conformance guidance. Now, what is of course very important is that before you can double check what is actually on our manufacturing restricted substance list and what is not, is that you have to know what is actually in your facility's inventory. Because if you don't have that insight, it will be very hard to control and also to make changes and find solutions and alternatives. So that is why within our program, and as well with a lot of our different stakeholders, we created a CIL template, a chemical inventory list template that can be used by suppliers to list their chemicals that they currently have within their facility. It's a list that should be kept at the facility, and is also, of course, a dynamic list, because your inventory changes over the time. And the basic expectation for a factory is to have a very robust system to list these chemicals, and also to make sure that their gap analysis can be made of what is missing, and to create a data list of the chemicals with also all the things attached to it. So the hazards, but also the CAS numbers, and all the different types of information you would need to list your chemistry and see how to use it as well in relation to, for instance, health and safety. So it's a list of chemicals and chemical products used in the facilities, in processing, but also in tooling and operations. And if there's anything missing in the list, or there's an issue with some of the chemicals information that you have for instance, the packaging or the labeling of your chemicals, or how do you receive them from the chemical formulator, it is expected of you that you connect with these formulators and obtain the data, so that you can list them properly in this chemical inventory list. Now, why should you in the end have it? As Shivandra already explained, there is a lot of chemicals that are hazardous, and there is a lot of need to control them in a way that they're also in terms of storage, production, health and safety, well processed. So it helps your organization to understand what you actually have in-house in your facility, and what you need to do to protect your environment, your company, let's say, facility, and also your employees. It enables you to analyze if you need to purchase more chemicals, but also different chemicals. So it's a very clear guidance on how to deal with your proper inventory in-house. And it enhances also your chemical management process via risk assessment. And based on that, you will be able to look for chemicals that are actually a substitution for the ones that are hazardous and that you still have in your inventory. Now the CIL together with the MRSL can be found back as well on our chemical module in the ZDHC gateway, which is the world's largest database of safer chemistry for the textile, footwear and leather and apparel industry. So basically the chemical module, which is one of the two modules in the gateway, contains a database already with substitutes for products that are on the ZDHC MRSL. Now, how does that practically work? And I think that's the most important part for you today, is that we have a chemical module that contains formulations from a lot of different chemical formulators that were uploaded by them on our platform. And so basically one of the biggest and important players in the platform is the actual chemical formulator. They are uploading MRSL conformant products on the ZDHC gateway. And these products are verified by us and by certification bodies so that we know that these products are indeed conformant to our MRSL and that we can show them actually to the brands and suppliers so that they will be able to find them and start to procure them for creating a safer chemical inventory. They can generate also reports to show you the proof that their products are conformant, and they can share it with their customers. As a supplier, you can search for these sustainable chemicals by checking the CIL that you were able to make with a template against the database of our MRSL in the gateway. And in that way, you can cross-check if your chemicals are actually MRSL conformant and also see which alternatives are actually available for you to procure instead. So it's a very practical way of controlling and checking your chemical inventory. Now, brands can also search for sustainable chemistry, and with that also go into the dialogue with the supplier to talk about which chemicals they feel should be used and are preferred to use for their production. So in that sense, there's a very close connection between the formulators, the suppliers, and the brands together in the platform to make sure that the path is set for more safer chemistry within the supply chain. Everybody can also create a connection, so suppliers can be connected to the brand and vice versa. But I think what is very important is that all the three members within the module are able to support each other and also push each other into the right direction. So a supplier who sees that certain formulations are not yet in the platform can ask their chemical formulator and chemical supplier to actually start to work with the ZDHC gateway to upload their chemistry into that gateway so they can also purchase them in the future. The brands can ask the supplier and the formulator to use more safer chemistry and upload that chemistry into the platform. And as well, the formulator can inform the supplier and the brand that there's more safer chemistry available. So basically, it's a rotating circle where everybody supports each other in the path of safer chemistry. Now, Shivandra was already mentioning that we are also working with, of course, with other lists that are available out there. So Shivandra was mentioning already bluesign. In ways we don't want to duplicate. So what we have done is that we are working as well with all the accepted conformance indicators currently important in the industry that we actually integrate in our ZDHC MRSL. So for instance, Ocotex, bluesign, indeed, they're also all connected to our ZDHC MRSL and the gateway to make sure that we don't create too much duplication within the industry, but that we are basically using them as a conformance indicator as well towards our ZDHC MRSL. How that works, you will be able to find in more detail as well in some of our other webinars that we have. Now, if as a supplier, and I will try to speed it up a little bit more, you are aware of your chemical inventory and you do a cross-check towards the ZDHC MRSL, you're also able to create an in-check report, which actually shows you which chemicals are compliant or conforming to the MRSL, which ones you should potentially be substituting. So it will give you a very clear report of your chemical inventory list cross-checked with your ZDHC MRSL. It's all available via the ZDHC gateway, and it does have a performance in-check provider solution to it, which is also can be reviewed at our website as well. So we work together with, for example, Beehive, CleanChain, BVE3, to actually look at creating this in-check tool for you, and also not duplicating again, but working together with these other companies to, in the end, also verify the documentation that you are cross-checking with our ZDHC MRSL. Now, all this comes together in the end in your total chemical management system approach, I would say. So the in-check part, or the input part of your chemical management journey is, of course, part of the whole journey, also related to process and output management. And to be able to give you more tools to work on that specific chemical management system, including the CIL, how to set it up, how to work with it, how to work with the gateway, how to update your chemical inventory list. We have created several webinars as well as training that will support the industry to use these tools. So on our ZDHC Academy platform, you can find a lot of different webinars specifically related to the ZDHC gateway and the input area, and also to our ZDHC MRSL. Next to that, we have training in the Academy that is containing all information about the CMS TIG, our technical industry guide, that will, from A to Z, walk you through how to implement a chemical management system, including a chemical management inventory, risk analysis, root cause analysis, and how to substitute chemicals that are in your hazardous chemicals that are in your inventory. So if you want to learn more than we can tell you in these 15 minutes, then please also go to our Academy website to review some of the webinars that are available, or sign up for one of the trainings that we are giving worldwide, in basically all the production countries. Then one additional tool that I would like to inform you about is our ZDHC knowledge base. In the knowledge base, all the different parts of ZDHC are highlighted, but you can also find, for example, links and downloads to the information that I've just given you. So, for instance, in relation to the gateway, you will be able to find the CIL template in the knowledge base itself by searching for CIL, and you will be able to download it there. Also, the links to the gateway and information on how to use the gateway can be found in the ZDHC knowledge base. So if you have a lot of questions around that, please review the knowledge base sessions and have a look if the information is sufficient to you. If not, of course, as a team, we are always available for you, and you can reach out to us via our email address, so that Phil and I and the rest of the team can support you with all of your questions. And do not forget, a trainer was just also in the room. Also, the trainers of ZDHC can always help you with the questions that you have around this topic. Thank you very much. I will leave it to that.
Thank you very much, Mariella Noto, for this also very interesting presentation. And again, you can get access to all the presentation at the asiagarmenthub.net. We will upload them there. A lot of people are asking how they can get hold of it. And thanks for the hint. Reach out to Mariella and her colleagues if you have any questions. So I wanted to ask all the speakers to go on camera. Here we are. So I wanted to, first of all, thank you all three again for your inputs and being so much on time. Fantastic. So we have 15 minutes left for question and answers, and we have collected a number of them from the chat. And if we have any more time, maybe I can take one or two more extra, and then we wrap it up with some final observation by Gundolf. So let me start maybe with Dr. Klaus, and I can ask you all to be very brief, as much as you can be brief on the question. And there were two questions, I think, addressed to you, Dr. Klaus. One was how 90% of initial chemicals are still present in post-consumer textiles. And the second one, if I just throw it at you right away, how to transform green chemistry into screened chemistry. Any thoughts on that?
Thank you. There are basic chemical and physical mechanisms. Yeah, so if some of the chemicals you want really that they stay on the fiber. So by adsorption, that means physical chemical interaction, by charges, by chemical bonds you're creating. So that's the normal stuff you're doing. And these mechanisms also work with the chemicals you use, but you do not want to have intentionally on the fibers. And if there's a chemical bond, then probably it takes a little bit longer until they are released, yeah, because the bond has to be broken. But if there are physical chemical processes like adsorption by charges, then it can happen faster and depends on the environment you are. And also then, to be honest, I have no idea what screen chemistry is, but I could imagine that green chemistry, or let's say green chemicals, so chemicals that have been synthesized according to the 12 principles of green chemistry, are a building block. If I assume that green chemicals are the good ones, with better properties, greener properties, more sustainable. But maybe someone else can explain this briefly, what green chemicals are.
Any comment on the screened chemistry?
Can Mr. Phil say something on this? Mariella? Mr. Phil is also with us, I think.
Yes, hello. Good morning. Hi. Yeah, green chemistry. I guess the term green chemistry is kind of a loose term, so to speak, right? That there's no sort of hard and fast definition. But the general consensus is that something, you know, is a sort of chemistry that is more, well, friendlier, quote unquote, to the environment. But you know, it's not just down to the chemistry itself. It's not just down to the chemical itself. But you also need to pay attention to the manufacturing process, right? For example, temperature control, how you handling it safely. There's a whole series of actions that you need to take care of to ensure that it does not either lead to the environment somehow, or minimize the exposure to the workers or the environment. That's just my 2 cents on that. In terms of green chemistry.
Thank you very much, Mr. Phil. So let's move on, because we have quite a number of questions here. Maybe quick questions to Shivendra. Let me fire it at you. Can I get a 1-year fail report for this type of banned chemicals from TÜV Rheinland? You saw that question in the chat, Shivendra?
Yeah, we have like Ms. Mariella has mentioned about that there are certain banned chemicals as per ZDHC HAMARE level 1. So we have the list available online also, and if you want, we can share also that list. No issue.
And there was a question also, is there any open database available to find alternative products and to conduct RCA? I think that's something also Mariella mentioned, right? So Shivendra or Mariella on that one.
Yeah, I guess, I mean, next to, of course, the other organizations that we work with, yes, indeed, in the ZDHC gateway, the database is completely open. So what you can do is actually register for free on the ZDHC gateway. So to register itself, it doesn't cost anything. And you can go into the database to search specific chemistry. The ZDHC MRSL is also online and is also a search tool. So basically what you can do, and I think, you know, also maybe via, because some people say, yeah, can you share the list? Maybe we can share some links afterwards with this information. People can go to the ZDHC MRSL online, basically fill in the cost numbers, for instance, or search on another term, and then find information in the ZDHC MRSL. So, and also in the candidate list, by the way, because that was one of the other questions. So it's a dynamic search tool. So I think the best thing we could do is actually to share maybe, you know, via the organization, some of the links that we have, so that people can look at it themselves. Basically online, because it's an online tool.
Thank you. I think several people actually asked a question. Please advise the status of phasing out perfluorochemicals, PFC, in textile. Anybody who would like to respond to that?
Maybe I can say a few words, not focused on textiles, but in general. I mentioned some of the latest initiatives of European Union within the Green Deal. Another one is directly focused on the one hand to endocrine disruptors, how to phase them out as soon as possible. And the same is also organic fluorinated compounds, all of them. And there will be a change in regulation also, that in the future probably there will be a different assessment. Yeah, because we have, if we talk about these compounds or group of compounds, we are talking about more or less 4,000 different chemicals. So that's not possible to have an individual assessment. And all have more or less the same unwanted properties, and therefore there will probably a group approach. So do not think about in the future to substitute one which will be banned by another. Sooner or later, all of them have to be phased out.
Thank you, Dr. Klaus. And I see a question here of Arun Hariharan. He asks, if my input is 100% compliance, can we eliminate the wastewater module? This was related to the presentation of Shivendra.
Because we are from the third party, but based on the feedback from the different industries, I just want to share that they are having got good results and output when we can talk about that using a non-hazardous chemical at the initial level. So it depends upon that, and further it also depend upon the wet processing, like different types of concentrations they are using in their wet processing. So if the certain chemical is having use for a higher concentration, so automatically their hazardous content will be increased. So it depends upon the quantity of the chemical usage also. So that is also the thing, and type of technique which they are using in the wet processing. But I must say that when we talk about the use of non-hazardous at the initial level, so there is some limit, the content concentration level, or there is that up to that it is considered as a non-detected, and if exceed that level it is considered as a detection. So that's the thing we need to consider, and we need to think on that. We need to check with our chemical supplier and formulator to just comply with our buyer's requirement, our legal government requirement, that whether it fulfill their requirement based on their usage in the wet processing.
Thank you. I think we're doing good. We're answering a lot of questions here. Yes.
Can I add just one more thing to what Shivana just mentioned about the wastewater discharge? I mean, having input control, the process control is fantastic, right? But I think a lot of time when the industry talk about, the discharge, they kind of forgotten about the wastewater operator, right? They all often think about the wastewater treatment plant does magic, right? Somehow they sort of wave the magic wand, wastewater comes out perfectly fine. But that's not the case. You also need to involve the wastewater operator in this dialogue as a whole holistic chemical management team to figure out how to control your output as well. You know, when we looked at the data, in the wastewater module, there are not many non-conforming result, but when we do see non-conforming result, the majority of the non-conformance comes from the conventional parameters, right? So the BOD, the COD, we're not talking about MRSLs, right? So those are the things that maybe the factory need to think about. You need to engage with the operator also, but that's my observation in general in the industry.
Thank you, Phil. We have 5 minutes left, so as short as possible. Danish Anwar was asking, what are the basic principles to root cause analysis of any ZDHC MRSL substance which detect in product or wastewater? I think it's a question for Shivendra, right?
When we talk about the root cause analysis, it is just like a complete process review. What parameter has been detected in your wastewater? Then, well, like for example, when we talk about APO, if it has been detected in the wastewater, then at the initial level, we have to just gone through the complete like the fishbone diagram technique. So whether it is a manufacturing related, the raw material related problem, whether it is the technique or the procedure related problem is there, because sometimes if you are using non-hazardous also if the concentration level, and that is also, so it depends of process need to be verified. It is the human error related issues there. And first of all, that particular process like desizing, sizing, or which particular process the issue is there, and then we have to segregate out, okay, this particular which particular chemical which may cause the problem. So with the help of the MSDS review, we can find out the content, the hazardous content in that particular chemical, and then come out with the thing, okay, this is the defaulter which create the detection in the wastewater. So that's how, and we are referring different types of documents online, like I given the reference of AFAM also, where all the details are available. So we can find out the sources which has been mentioned related to that chemical parameter. And that's how we can find out, okay, this is the thing. And as I told you, like we can choose for the alternative for that, or either we have the another issue related to the wet processing. So based on their expertise for that wet processing, that particular process, whether it's a dyeing, sizing, or finishing, so they can make the changes accordingly.
Thank you. So Ali was asking how much percentage of chemicals should be ZDHC approved of total chemicals accepted by most of brands. Any takers for this question? Phil or Mariella?
I could take it, I suppose, but it's really hard to say the exact percentage, right? Because each brand are asking slightly different thing. But the gateway, the ZDHC gateway, acts as a facilitator to help the factory, to achieve what the brand is asking of them. So if your brand say, hey, that's 80%, then you should be aiming for that. But again, if you're working for multiple brands, for example, some say, okay, maybe achieve 50%, some say 60, some say 70. Let's go for the toughest requirement, right? The more aspirational requirement. It's all you can think of it as a so-called regulatory assessment, right? You need to, find the toughest requirements of all of them.
Yeah, and by the end of it, of course, your aim is that you want to eliminate as much as possible and go for 100%, right? That, I mean, intrinsically, for the environment and health and safety, and you want to go, as like Phil says, to the maximum, because in the end, of course, you want to eliminate as much as possible. I also see,
So
by the way, a
looking at
hand up.
Yeah, actually,
Yeah,
it's Dr. Klaus who would
Chris.
like to respond as well. And I think, Dr. Klaus, you might be the last commentator, but there are more questions coming in. If anything, you can answer like Mariella just did to one question in the chat. Please do so. Dr. Klaus, maybe
Yeah,
last
I just would
response.
support this. You should not only look on your customers, you should go ahead, you should be an innovator, and then you are also prepared. That's a good part of it. If the standards are rising, you are already prepared, you are already there.
Yeah.
So do not only what you have to do, think of the future, what you can do.
Think of the future, what you
Absolutely.
can do. Yes, we are running out of time, but there are more webinars coming. But first of all, there will be a link any second in the chat that you can give us a little bit feedback. Feedback it's 1 Mentimeter question. Please, everybody in this webinar, our sponsors, they always appreciate if we get feedback. So if you felt that this was a valuable 90 minutes for you, then please let us know. There are so many more questions coming. Sorry that we don't have enough time to answer them, but I will hand over for the last 2-3 minutes for final observations to Gundolf, who was listening very carefully, and I asked him ahead of the webinar to listen carefully and maybe try to give us 3 key takeaways from what he has learned and heard so far. Gundolf, over to you.
Thank you very much. Yeah, thanks as well first to the presenter and speaker. Was, I think, very, as we can see, that question still coming in, that was also very much helpful for the audience. And the last words, Klaus Klummer, that brings me to my first key takeaway, somehow preparing for the future. So I think one message is, and that is very much important, also thinking already in the beginning what will be the end of the product or how the product will look at the end. So means making, you had this quite nice quote there, make things more green. That starts already at the design. Yeah. So, and that is, I think, a very important message already towards the brands. So when you want to be more sustainable, consider already at the point when you're designing your products, how to make it more sustainable. And there were also one more point you said, so less chemicals is reduced, means that you're reducing the complexity, and this can save time and cost, which is also then very much important for the producer. And another key takeaway, I think it's very much important, and it's also somehow reflecting the questions still coming in, understand really what you're using. I think that is very much important. That is nothing new. That's a message we also from GIZ. When it comes to improvement of chemical management on site at the facilities, first thing, make an evaluation, understand what you're using, set up a proper inventory. Yeah? So you can do it on a small scale on a facility, but also then a bit larger when it comes to the whole life cycle. So here as well, our brands, I think, also needed to consider that it's not like making a design, placing the order. The responsibility is on both sides, on the producer side and also on the buyer side. Understand really what you are using. And I think, and the third key takeaway I think is very much important is, yeah, also somehow reflecting the messages coming in, also what was presented by Shivendra and Mariella. We need knowledge and we need access to that. So that means, to make it very practical, there are tools there, of course, ZDHC, that's also why we invite them, and we are very happy to that. There are a lot of tools there, and it's not always so easy to find all them. We know that. That's also why we provide these messages. We want to foster the knowledge exchange and sharing the experiences. Knowledge and transparency is very much important. And I think when we have to prepare for the future, it does not make sense to hide anything where it's not going well. I know for the producer side, they always afraid a bit sometimes, yeah, when they're not being full 100, fully compliant with the brand requirements. Nevertheless, if you're not looking at your problems, it's very much very difficult to improve yourself. And we have not seen so far so much really what does it mean regarding cost, just a nice quote, less chemicals means less complexity, which will which means then that you can save time and cost. But in the next 2 sessions, we will explicitly getting very practical examples also from chemical suppliers who present also what does it mean for the producer by using the green chemicals regarding the cost aspect. Thank you very much from my side.
Thank you, Gundolf. So you already mentioned the journey goes on our journey of making textiles green. So how it is transforming the textiles. So next week, same time, kind of same location. I hope you have registered already. Some people already indicating they are joining next week. Hopefully you all then know how to work, to ask questions and engage in comments. So hope to see many of you next week. And once again, thanks to our speakers, Klaus Kümmerer, Shivendra Parma, and Mariela Noto. Also thanks to Phil for joining in last minute and answering questions. So this is it for today. We wish you a good afternoon or nice lunch, depending where you are, I guess. And hope to see many of you next week. And don't forget, asiagarmenthub.net. The colleagues will upload very shortly the presentations and additional information as it is available. So see you next week, and thank you very much for joining today. And do not forget to click on menti.com in the chat. It takes only 2 minutes, I promise. We would like to have large numbers who give feedback. It's just a ranking from 1 to 5. Thank you so much. Have a good day.
Thank you. Have a good day.
Thank you. Have a nice day.
And thanks to all the comments in the chat, and thanks for the questions. Sorry that we couldn't answer all of them. So we leave the room maybe open for what we call backstage, if anybody wants to say something. Otherwise, we close it now, right?